So I have a vector, force, obviously. That's what we deal with in this course. Its magnitude is 100 pounds. I'm given the magnitude of the vector. And I'm given the angle it creates, not, well, I'm giving two angles. What these angles are not exactly the angles that the vector creates with different axes. But like that 60 degrees is the angle that the vector creates with XY plane, and 45 degrees is the angle that the projection of the vector on XY plane creates with X axis. So it's a little things are moved around. Let's see how do we deal with that. How do we deal with that? So the problem says express the force vector F in Cartesian space that's pretty much it. And also it says also find the unit vector, find the unit vector acting in the direction, this is direction, in the direction of F, of vector F. Oh, it continues. In direction of F, and apparently doesn't allow us to go that easily, and direction angles. And when we say direction angles, by direction angles, we mean the angles that the vector creates with the axes, X, Y, Z axes. So how do I do this one? One thing I know is the, let me change the colors a little bit and get into more useful set. So one thing I know is the magnitude of this is 100 pounds. That is there. That's a given information. So how can I find this? Where do I start? Any suggestion? Anyone has anything in mind? What can I do now? I talked about vector, unit vectors and everything, and now I'm at this point that I'm given some information. I have to kind of use whatever we talked about to figure this out.
Would it be a free body diagram?
Well, just put free body diagram aside for the rest of this class, I would say. We're dealing with vectors, so there is no equilibrium or anything. So we're just talking about the concept of vectors. We can just look at this F as a vector. It's just a vector, and use whatever we learned about vectors in 3D space to figure this out.
Like break it into XY components?
Yeah, well, we can start from there. One thing I can do is that, well, I'm given this magnitude, 100 pounds. So I can find actually Z components already. This is FZ. What was FZ from the definition? Well, FZ was the magnitude of F and the cosine this vector creates with Z axis, right? This angle, which we call gamma. Now, what is gamma? Well, gamma is, well, 100 times cosine. This whole angle is 90. I know this part is 60 degrees, so that would be 30 degrees. So let me write it this way. Would be cosine 90 minus 30. 90 minus 60. Where did I get 30? 30 is the final outcome. The other way of doing this is that, well, just take a look at this triangle. Take a look at this triangle there. This triangle, oops, That's not where I was trying to go. Take a look at this triangle. This is FZ, right, along these two lines. I know this is 60 degrees, so this is a right triangle here. I know this is 60 degrees. I know the magnitude or hypotenuse in this case is 100. So I can just go with the definition. So we can just say, or you can just say sine 60 degrees is equal to FZ over the magnitude of F. Right? So we can find FZ by just saying magnitude of F multiplied by sine 60 degrees. Right? Either this or that. You'll get the value for FZ, or the component of this vector along z-axis. Did that make sense? Do you need the angle to the y-axis? Well, we do need that, but we'll get there. Right? I'm just focused on the component of z. I said I can find that immediately by the information I'm given and by looking at this without going further into details. So this is FZ. Just make sure that you got, how did I get FZ? If you do this math, it'll give you, well, both of them give you the same number, 86.6 pounds. 86.6 pounds. It's supposed to be 8. Okay, so we found the component in z direction. What about the other ones? How do we deal with the other ones? We have to find the components in along x and y to be able to represent this vector in Cartesian space. So as Connor said, we need to find the angles, right? The angles alpha and beta, and we don't have them. But we can use the geometry that we are given. Right? We know that, let me erase this part, it's crowded here. So we know, we don't need that, there you go. Looking at the same angle, triangle, right here, this triangle there, we can find this length. Right? I call this F prime for the lack of better letter. What is F prime? F prime if the projection of F on X, Y plane. So let me write it here. Component of F, or projection of F on XY plane. Right. Now, what is the value of F prime? Can someone tell me? Looking at this triangle, and this is a right triangle, we know the hypotenuse is 100. We know this angle is 60 degrees. What is the value of F prime?
$50.
Craig, I heard you said something.
Oh, 50.
50, yeah. I'll give the final number. It would be the magnitude, thank you, cosine 60 degrees. And I'll give you 100 cosine 60 degrees, will give you 50, as he said. So what do we have now? Now we have, going step by step, we have looking at from the top. Now we have this situation. I have this vector, which is called F prime, which I called it F prime. Right. This angle here is 45 degrees, and to get a better sense, this is Y, this is X. Right? I'm looking at this from the top. This is supposed to be an I, so I don't think eyes emit light, but you get the idea. I'm looking from the top, right? XY plane. So in XY plane, now this is F prime. This is 45 degrees. So if you look at this, and we can find these components, right? These components are going to be your fx and fy. Think about this for a moment. Make sure you understand what is going on here. I found the component on xy plane, and I said, well, I know this is a component on xy plane, so I'm going to go one step further and use this component on xy plane and the information that I have about the angle this force creates with x-axis to find the component along x and y axis. So I'm going to move ahead, assuming that if it's still confusing, you guys are going to stop me. Plus, also the case if I made a mistake somewhere. Fx is f prime. Right? So what is fx? Assuming that I know this is 40. Sorry, Craig, go ahead.
Oh, f prime times cosine of 45.
Cosine 45. Be very comfortable with these angles and how to find side and adjacent and hypotenuse, knowing different angles in a right triangle. You're going to use that very, very frequently, over and over. So be very comfortable with finding the components, knowing hypotenuse, or finding hypotenuse, knowing one side or adjacent or opposite side in a right triangle. So f prime cosine 45 degrees. This will give you, it's going to be 50, so it's going to be 25 square root of 2 pound. You can find fy too, right? Fy would be f prime sine 45 degrees. So that will give you the same thing, but pay attention, fy is negative, right? This is the origin. Fy is towards the left, so that would be minus 25 square root of 2 pounds. So I got my fz, I got my fx, and I got my fy. I can now answer the first part. I can write this vector f in Cartesian space. So let's do that. Vector f is nothing but fxi plus fyj plus fzk. Now the values was 25 square root of 2i minus 25 square root of 2j, and the last one was 86.6. 86.6 K. The unit is pounds. So that's F. It's the first part of the problem solved. Now the second part was asking us to find the unit vector and the direction angles, alpha, beta, and gamma. How do I do that now that I know what the vector is? Go back, so previous page, this one. So I know what F is. I want to find the unit vector. I'm just going to use what I introduced from before, right, at the beginning. Not exactly at the beginning. Here, if you know this equation, if you know what the components are, this equation, what the components are, and you know the magnitude, right, we can find the unit vector. So go back there. I have the magnitude is 100, and I know the vector, so I just divide. Right? So unit vector, I'll call it UF, would be the vector F divided by the magnitude of vector F. We can just write it again as Fx, Fi plus Fy over the magnitude of Fj plus Fz divided the magnitude of Fk. 25 square root of 2 divided by 100. I think I did the math to give you the number. It's 0.35. I think 0.35. Believe it or not, I can't read my own handwriting. It's either 4 or 9. I really feel bad for you that you have to read my handwriting now and understand what kind of struggle you're going through. I believe it's 4, but if you do the math and you got 9, go with 9. So the same number is negative j, and that one divided by 100, so 0.866k. So this is the unit vector. The last part, all right, we found the vector, we found the unit vector for that vector. The last part was asking us to find the direction angles, alpha, beta, and gamma, or theta x, theta y, and theta z. To make sure I give enough space to both notations, I use theta x here. Theta x is cosine inverse fx divided by magnitude of f. Theta y is cosine inverse fy divided by magnitude of f. Okay? And theta z is cosine inverse fz divided by magnitude of f. So these are going to be the angles. Pretty much you have everything you need. You have fx, the component along x, you have f, and keep in mind these are pretty much just these values, right? Because these are directional angles. This is cosine alpha, this is cosine beta, and this is cosine gamma. So if you find the inverse, you get pretty much these same numbers. So if you do the math here, I actually found them in degrees. So that would be 69.27 degrees. Theta y or beta was, I believe, 110.73. And theta z, I got 30 degrees, which should be, I guess, 30 already is given. Yeah, it's gamma, it's 30 degrees. We already know that. Would have been weird if I got something different. You didn't even have to calculate that. It was already there. So, question about this example, guys. So what I did was, well, I pretty much tried to just do an example so we can refresh our mind about vectors in 3D space. I gave you a couple of equations, but not always equations are the first thing you have to think about. Think about the geometry. Sometimes you can easily just decompose the vector along a specific plane and use the information you have.